Hi, I'm Sai Krishna. So for the question 5, we are told that we have to let us assume that there are 100 people waiting for a certain kind of blood test of certain disease, and that the probability that one person testing positive is given as 0.1. Okay, and then there are two methods that these blood tests follow. Method 1 is that each person, one after the other, is tested, and then there are about 100 tests. And in the second method, the total people, that is 100 people, are divided into 10 groups, each consisting of 10 people, and then these 10 people blood is mixed and the mixture is tested. If at all the mixture tested is negative, then everybody in the group is tested negative. If the resultant mixture is tested positive, then the people in the group have to be tested one by one. That basically turns out to be 11 tests in the worst case. So here we are asked to find out the number of tests we need to do on an average in the second method. So let us look at the solution for this. So question 5. So we are told that the probability that a person testing positive equals 0.1. So a person not testing positive equals 1 minus 0.1, which turns out to be 0.9. Okay, so basically let K be the number of tests to be done to a group. Okay, so here basically K in the best case is 1, because the group, if it tests negative, then there is only one test to do. If at all the group group mixture is tested positive, then we have to do 11 tests, basically the one test at the beginning and then 10 tests done to individual people. Okay, so basically we have to calculate the average tests to be done in second method. Okay, so average can be calculated as P of K equal to 1 plus 11 into P of K equal to 11. So let me explain this. So P of K, I've written P of K equal to 1 because in the best case there is only one test to be done where the mixture is tested negative. Okay, and then I've added that to P of K equal to 11 because in the worst case the mixture is tested positive and there are 10 more tests to be done, which basically turns out to be 1 plus 10. So there are 11 tests in total, so 11 here, and the probability of worst case P of K equal to 11. So this can be written as so here we have to remember that this is the negative scenario where a mixture is tested negative. So it is 0.9 and then all the people have tested negative, so it's 0.9 to the power of 10 plus 11 into 1 minus 0.9 to the power of 10. Yeah, so I've written 1 minus 0.9 to the power of 10 because in the first case it is tested positive and then I'm doing 10 more tests where I will be finding out who is positive. So it is a case where not all are positive. Okay, sorry, not all are negative. Okay, so this is the case. So let me calculate this. This is 0.9 to the power of 10 plus 11 into 1 minus 0.9 to the power of 10. So here is a calculator. So 0.9 to the power of 10 equals 0.3486. So let me write this here, 0.3486. So here it is 11 into 1 minus 0.9 0.3486 because 0.9 we have calculated at this. Yes, so here 1 minus 0.3486 equals 0.6514. So it's 0.3486 plus 11 into 0.6514. Yeah. So it's 0.3486 plus 11 into 0.6514 equals into 11 equals plus 7.1654. I've calculated it here, and then 0.3486. So on addition of 0.3486, this turns out to be 7.514. Yes. Okay, so but I have just calculated it for 10 people. Okay, but there are 100 people. So for average test to be done for 100 people equals 10, because there are 10 groups, into 7.514. We have just calculated that. Okay, so it's equals 75.14, which is almost equal to 75. So there are 75 tests to be done. So thank you. This is the explanation.